towards the Sustainable Development Goals. For those of us that perhaps aren't overly familiar with the SDGs, it's very much a holistic framework for tackling some of the world's biggest problems. I think I show my age sometimes, but they're often described as the world's wicked problems, which where I was growing up often meant something slightly different. But they're some of the most kind of key pressing environmental and societal issues that the world is currently facing. And the idea is that what we want to do is try and build a transformative approach to kind of tackling a lot of those issues. And a lot of those issues kind of mirror a lot of what was spoken about this morning and mirror a lot of what we talk about when we're talking about justification for why we're doing something. But particularly with our students, the why we're using GIS, why we're learning these skills has been a key thing over the last few years. Why are we learning? What is a projection? What is a spatial data model? How can that actually work in the real world? And that's been quite eye-opening, because one of the key things with GIS is that ability to make informed decisions, right? And informed decision making is probably my most overused term in my teaching, but the idea that we can use GIS to create this layered view of the world, but actually put it into this kind of holistic framework. And that was also the other big thing as well, that a lot of our students going into the workplace wanted to know. Said, look, we can do all of this stuff. We can show the ability or the I can't think of the term, but the usefulness of what we're doing. But can we actually put that into a system, into a framework that everybody knows? And so the SDGs has certainly been something that we've been trying to work on as a collective down at UCC, but particularly within the GIS program as well, because ultimately, if you can actually demonstrate that measurable, quantifiable impact that you're doing, not just at the local, but at the global scale as well. And most countries are having to report on these. What it does is it allows us to kind of really show the ability of what GIS and particularly kind of open source GIS can do. So why Phosphor-G and why have we implemented it through this system? And again, this is often kind of a discussion of what we're doing, but kind of COVID, the pandemic, the remote working really kind of stifled undergrad teaching in particular. All of a sudden, when you'd have students coming into a lab and these large lab bases where you're able to do kind of practical problem solving in and around, all of a sudden that wasn't possible. And the ability to kind of actually work through students and problem solve with students in and around those issues became highly problematic. And coupled with the fact that whilst people can remote work and they do have access to the devices, those devices aren't always operational with all of the different types of software. I am preaching to everyone that kind of does that, but particularly when we're talking about like undergrad teaching and what we can do there, it's important. But likewise, when you're talking about some of the bigger issues and the bigger challenges, we want to make sure that those challenges are accessible for everyone, right? And that leave no one behind is the transformative message. And so therefore, price shouldn't be a factor towards it. So that open nature, that open source consideration is kind of key. This isn't a plug, but like that coincided quite nicely with an opportunity to kind of try and actually formalize some of this as a textbook. And so kind of, that came out earlier this year, but looking at actually formalizing not just class material, because oftentimes everyone does this great work, right? Everyone's doing this great work and developing these things, but actually how you can put that forward and demonstrate that link between teaching, what our students, what the future kind of citizens of geospatial are doing, coupled with the research, coupled with the active kind of nature of what we want to do, and actually see how we can actually begin to do that. And so the idea behind what I'm going to talk about today is try and just give two quick case studies. They're both sort of linked to kind of the book, but the first one is certainly going to be focused more on a Med-Erin funded project that we've been working on to show how we can use open source GIS and open source data to support climate action, and particularly SDG 13, and then kind of actually fortuitously building on some of the talks of the previous session, look at sustainable cities and particularly look at how we can provide more accessible and safe walking locations. And so there's some of the two of the examples that I'm just going to kind of work through and talk about what we're doing there. So climate risk, and this is something that we've been working on for the last 2 years between UCC and iCheck, and Enda O'Brien and Paul Nolan have been developing new standardized climate projections for Ireland, and you can see them there in that article. Our part of that project is to develop a standardization for quantifying climate risk. And so the idea is that it builds into the climate adaptation frameworks, right? It builds into the sectoral plans and how we can use open source software, open source data to actually kind of support those firms such as climate resilience, climate adaptation, climate mitigation. And again, the kind of key message is knowing where something is happening, knowing where that risk is perhaps amplified is kind of key. And so not just kind of teachings in that bottom left-hand figure there, not just talking about spatial data models, but saying how can spatial data models represent temperature changes? How can they represent features? And how can you link those two together? So you're actually answering a specific question. You're actually linking that back to the SDGs. You're actually linking that back to what we're talking about. And so you're not just kind of understanding the theory, you're actually understanding the practical consideration of what you're doing. And I think when that link becomes clear, that's when actually the power of what we're doing really becomes amplified. And so as part of the Translate project and our team, what we've done is we've developed this 6-step framework that will be hopefully used by the different sectors to generate climate risk across the different organizations. So identifying, kind of linking in with the IPC definition of risk, which is hazard and vulnerability and exposure. You have a hazard, a climate hazard, and in this case, that can mean various things. You have exposure to a certain phenomena, and you have vulnerability to that specific formula. And so it's a 6-step process in our consideration, identifying those hazards and generating those hazards in spatial data. Similarly, identifying and sourcing those geospatial variables of vulnerability and exposure, creating an overarching aggregate grid to be able to work with that, aggregating that data to the grid, indexing this, and then calculating that risk. And again, this perhaps might not seem, for all of us as GIS experts in this room, it might not seem that creating risk, creating weighted risk, creating those sort of indices is something that we do. But actually kind of shifting that out to the sectors, the people that are making those key decisions, talking about where we're going to plan, where we're going to shift resources, where we're going to focus that's something that's kind of very key. And so what we've done is we went to the sectors and said, look, what are some of the key climate hazards that you're interested in? What are some of the key things that will make you focus on those decisions? We talked to transport, we talked to housing, we talked to schools, we talked to various different organizations, agriculture and all of that. And you can see there that there's a list of certain kind of hazard indicators that they're making decisions on. I appreciate the writing is a little bit small, but we're talking about, say, wet days, or as we approach an unusual September yellow weather warning for hot weather. I think we're in one now, right, at the national thing. The yellow weather warnings. The weather warnings are actually kind of one of the key indicators that a lot of sectors, a lot of organizations make decisions on. When to make a decision on closing or changing an appointment or closing an organization, such as a school. And so what we've done is we've taken the high resolution projection data and developed code and developed that pipeline that we can be able to say, okay, right, we've got these data. And I'm not sure if anyone's kind of worked with kind of GRIB2 files, NetCDF files. It's great, but it's not necessarily easily translatable to someone that's trying to work with it. So the whole point of this is taking that data and trying to create a set of spatial layers that are out there that can be easily downloaded as a single TIFF or as a multi-band raster to be able to use by these different organizations. So that's kind of step one, but then trying to identify what those specific hazards are. And that will change depending on the different types of features that we're interested in. Right, some of them are ubiquitous. People will probably make decisions based on the weather warnings. That's probably one thing. But they'll probably change over time. But we had a project that kind of was looking at, well, what is too much rain for an endangered bird? That was one project that we've just kind of been working on. Some colleagues in the room of Compass have been working on. So that, but it's like when it's less than 5 degrees Celsius out there and it rains too much, these birds struggle. But that's a very species specific thing. So thinking of agriculture. What is the threshold of growing degree days for specific crops? What is the threshold for kind of a lower critical limit for an endangered creature? All of those sort of things, they're very sector specific. So rather than us creating different indices to say, this is the indicator, it's going to be 5 degrees, or it's going to be 6 degrees, or it's going to be 7 degrees, it's creating that pipeline that someone can go to that data, plug it into an API or an app, and develop their own kind of thing. So it's processing there, it generates out these outputs, and it's subsequently very easy to use in terms of predicting risk and hazard and all of those things. And so you can see there, that's the number of extreme rain days based on the Met-Air and orange weather warnings that we had between 1976 and 2005. So you can see there that the spatial distribution of where that is, but you can begin to not just take the current level or the historic observations, but look at the future projections as well and see where that's going to change. And then particularly taking a lot of the existing tools, the existing infrastructure that you have in Python and QGIS and saying, well, let's aggregate this up to a grid. We chose the H3 Uber classification of hexagon grids to do that, but being able to kind of aggregate this up to a specific scale and doing this for both the hazard as well as the infrastructure data as well. So taking a kind of aggregate unit, but beginning to develop those features that we think are important. When we're talking about, say, maybe extreme flooding events, infrastructure, roads become important. What are the roads that are going to be subject to the most flooding? What are the roads that have perhaps no capacity for flash floods? Where might we need new culverts? Where might we need new drains? Which are the roads that are going to be subject to the most change over time? And so by implementing this procedure, we can say, right there, where are all the different schools in the country? Aggregate them to the grid. Look at the total population that are affiliated with those schools and begin to look at an index. And so we're saying, right, where are the highest exposure should a hazard occur? And you can see here in Ireland, unsurprisingly, it's dominated by Dublin. But it talks to the kind of risk isn't just related to the hazard, it's also related to the exposure. If more people or more features are going to be exposed to that hazard, then the risk increases. And so again, kind of aggregating hazards, this is a consideration of the number of heat days, cold days, and precipitation days. Exposure, in this case, it's total number of students, as we've just seen, and vulnerability, looking at deprivation and looking at access to broadband. And in this particular example, we're looking at the risk of missed education days. Schools is perhaps one of the key things. When the weather gets bad, schools and nurseries are one of the first things to close, right? Because it becomes unsafe for people to travel, it becomes unsafe for students to be in these areas, or potentially becomes unsafe. So what we're doing is saying, what is the potential risk of missed education days? So as climate changes, how might that be impacted? And so what we can do is we can predict current risk and we can project future risk. And you can begin to see there that we see some changes, but we can also map that and actually quantify that. And so we can begin to identify areas where the risk of missed education increases or decreases based on that change in climate, and specifically that change in climate hazard. We can add in change in population, change in deprivation projections, any kind of spatial data that we have, we can put in there. It's able to identify which schools are projected to have the largest changes under future climates. So focusing on just precipitation alone, that's Tralee and Donegal. So if we're talking about improving infrastructure or directing resources towards kind of climate adaptation or climate awareness, which would support SDG 13, or supporting education, which would be SDG 4, we can identify those areas as areas that perhaps might need more targeted resources to support missed education. But we can also look and say, well, where is that risk going to increase the most? And you can begin to see that's in and around Dublin, the suburbs of Dublin, where we're actually having kind of more projection, but also in and around Cork and all of those areas as well. But you can also see a decreased risk in some of the Midland areas. Some of the climate hazards, they're still increasing in frequency, but they're perhaps not as high as they perhaps were, as dominant as they were in terms of there's other areas that are perhaps getting worse in a quicker framework. So that's kind of the first example of how we can do that. And then specifically linking that into kind of spatial data models. You've got a bit of raster, you've got a bit of polygons, all of those sort of things, right? We've got all of that different spatial information there linking that. The second example that I kind of want to just kind of allude to and talk a little bit about kind of jumps all the way to the end. And this is kind of turned into a bit of a pet project, and it links very nicely to the earlier talks looking at accessibility and walkability, but just posing the question, what's the best route to get somewhere? So this was my poor planning and preparation at about 5:15 last night. How am I going to get up here tomorrow? But you can see there that that's probably my own fault for using Apple Maps, but you can see that we get whenever we use any of these apps, we get a choice of 3 features, right? And in this instance, it's the quickest route. I'm not sure why you would ever go to Galway to get to Maynooth, but anyway, it's up there as a suggestion. But you can begin to see that we make a lot of these decisions from an individual perspective, right? Often we're looking at where we are, we're looking at where we want to get to, and we're trying to identify the best route. It's a very individualistic or kind of idiosyncratic kind of thing. But we're saying, right, how do we get there? And this has kind of been something that I've been looking at. A lot of my research has been in terms of exploring animal movement, and particularly in recent years, kind of getting into, well, actually based in the city, we can actually begin to ask people why they make decisions. It's a lot harder to ask animals why they're making decisions. You have to make inferences. We can actually go out and ask people why they're making those decisions. And so again, linking this to the different SDGs, but also kind of working with colleagues and students to kind of say, well, look, what are the choices that people are making? And I think kind of coming at this from a Lagrangian approach to movement, or an individual approach to movement, kind of saying everyone is different. And if we link that back to the SDGs, that no one is left behind, this transformative vision, everyone has different views of why they make choices, how they make decisions, and how they get to places. And particularly in the next example, we're focusing on kind of safety and two perceptions of safety that we kind of bore out from the literature, but also kind of just some discussions of various things that have been happening socially in the last couple of years. And this kind of poses the question, what is the best route to take from the train station from 5 different tourist sites? And again, only using Edinburgh for the sake of kind of open data. They've got a great open data portal up there in Edinburgh. But kind of saying, if we take 4 different tourist sites in the city and try and identify the best route to the train station, what is that best route? And so again, if we take network analysis and we just simply use the shortest distance and looking at the street network, you can begin to see the 4 predominant routes that you would take there. But movement is your own choice. And we saw that this morning when we were talking about what defines accessibility. We had a comment on CO2, air pollution. Perhaps people make decisions on where they want to walk based on the quality of the air. Had a comment based on electric vehicles. Perhaps people are making choices based on that. It's a personal preference, right? Everyone kind of makes decisions based on their own experiences, based on their own needs, based on their own requirements. And so this is something that I kind of allude to here, that we can make decisions based on that. And so by building up a GIS infrastructure that allows people to make their own choices as to how they're going to make routes, we can begin to utilize all that spatial data that we have here. So you can begin to see this is just the least cost path method, but you can see the least cost path method that avoids high density derelict buildings and avoids low density CCTV. 2 things that from the literature and from discussions people associate with perceived safety as they move around the city. So you can see quite quickly there how the routes change based on a least cost path raster, kind of a kind of hybrid kind of Euclidean distance in a raster format. If we map those densities as speeds to the road network, you can begin to see the differences there as well. So you map the density values of that, project them onto the lines, and then use that as a speed value. So it's kind of almost creating the least cost path, but restrained to the street network. And you can begin to see the variation, right? You've got the shortest distance, and in some instances they don't differ from those locations, but particularly say you're coming in from the west there, I think that's the zoo. It's a similar path, but then it branches, and you get one area that walks through areas where there's a higher density of CCTV, or you have one that walks with a lower density of CCTV. And the idea is to kind of say, well, look, we can use GIS, we can use these open source data sets, we can use these open source kind of platforms and these tools to put the power back in individuals' hands and say, this is a decision that I want to make, rather than come at it from a top-down approach and saying, this is how we're going to suggest you move around the city. Almost puts the power back on the individual and say, given all of these data sets, given all of this availability, I can map my own route based on the features that I find interesting. And particularly when we talk about, say, sustainability and walkability, all of a sudden people are more likely to walk somewhere if they feel they have control over what they're doing with all of that. And we've had a master's student looking at some of this in Cork, similar situation, looking at the tourist sites, looking at that. Unsurprisingly, because he went out at Jazz Weekend, a lot of the results were geared towards bars and pubs and restaurants. So this is the variation in terms of getting to the different locations based on bars and pubs and restaurants. But again, it's a targeted thing for a specific weekend in Cork. Those might be the best routes to, say, maybe police, or maybe to provide extra support or to remove traffic, because you're reducing the potential for other conflicts that then feed into those other SDG targets. Oftentimes in some locations, the party weekends are some of the highest for serious injuries or fatalities along road networks. And if you can identify the routes that people are potentially taking and potentially increasing those conflicts, you can reduce those incidents. And then by reducing those instances, you're providing a measurable target to those quantifiable things that we're trying to look at here, and actually emphasize that ability of what we're doing with GIS to actually answer those questions. So yeah, that's everything that I've got. I hope that was on time. I didn't even start clapping myself down kind of saying that, but thanks for listening. Yeah, happy to take any questions.
Thank you. We'll leave the questions to the end.
Perfect. Yeah, and I don't need to comment.
Put me in a bind. What would you prefer, Paul?
I don't mind, Rishi. I'm happy to take any questions if there are any.
Well, yeah, maybe if you can just please come forward. I have a couple. I was taking notes. It's okay. Okay, let's open up for questions. You've heard Paul talk about SDGs and open source GIS. If you don't have one, then I'll begin.
Paul.
Yeah, what's up?
Just a question about the tools, I suppose,
Yeah.
that you use to develop this, and how they can be deployed, I suppose, and how they can be reusable.
Yeah.
I suppose this is, very interesting from a destination analysis perspective, aside from the development or goals and stuff.
Yeah. So I guess the idea is to try and, particularly for say the route selection and colleague that we work with just got some money to kind of work on that. So the idea is that we'll hopefully be developing an API or an app that will be able to, in first instance, collect the data, see where people are moving, and then they're going to append information to those routes. And so this is more about kind of mental cognition, so where they feel happy, where they feel most at ease, where they feel stressed, and begin to map that data. And then the idea is to take that data, train some specific models, and then kind of build that network and use ideally some of the inbuilt tools in the first instance to make it through, but through an online device so that they have this information on their phones. They're not necessarily having to go into those GIS applications on their phones or on the desktop, but they can say, right, I want to go out and I want to try and improve my happiness by 10% or whatever. Or I want to engage with nature, or this will hopefully kind of predict where the best route, or provide options as kind of in that, rather than say just this is going to avoid a toll road. This is a suggested route for happiness there, and do it that way. And so that's the idea.
It'd be very useful to see something like Google Maps, for example.
Yeah.
I think you had the Euro symbol on the 3 different churches from Apple Maps. But I suppose it's last year since they started putting out what's the most economic
fuel consumption and all that. Yeah. So it's more kind of it's almost that sort of concept, but from a very kind of walkable concept in terms of making those decisions.
Thank you. I have 2 questions, Paul. The first one being, you're preaching to the choir here, but FOSS clearly, at least in this room, has a role to play as far as SDG or addressing the SDG problems are concerned. I guess if you play the contrarian role, I was going to ask you, what are the challenges with FOSS, or if you had a magic wand, what would be your vision with this, let's say?
That's a great question, and I think it's uptake, right? And it's not about reskilling; it's about providing that opportunity and that infrastructure so that people can do it. If we go back to the Translate project and go back to that workshop, I think from like 80% to 85% of our participants said they use Desiree software, and so remits of European funding is it wants to be open source, it wants to be available for all. But if the sectors themselves aren't using it, then is that going to be uptaken? And so I think that's a key challenge that we're currently facing. And in the first iteration of that tool was all built in Python in the Anaconda environment, which is great, but people were not going to use it. Someone that is working at a specific sector without that background in computer science is not going to open up some of those files. So that's been one of our challenges about kind of building that pipeline and trying to automate it so that those decisions are taken away. We've got the infrastructure there to generate those indicators, but we're trying to do this in a method very similar to how you presented that work, that there's decisions that can be made in, say, maybe an API that then process it in the background, but aren't necessarily requiring people to significantly upskill in a new software or a new area.
Yes, you're saying FOSS can do a better job of packaging it or presenting it or making it a little bit more accessible than what it is now.
Potentially, I'll go on, Aki. You can say I'm saying something like that, yeah, for sure. But I also think it is a challenge that we're often taught one software and we think that software is GIS. And there's a certain level that we get to, right? Our students think that one software is the software that is teaching GIS, but actually it's not. And you can use multiple softwares to do the same thing, or you can get there. And so I think it's getting that message across that it's not either or. It's you use what's out there, and it's you're trying to link the theory to the practical skills, and the practical skills themselves aren't the end product.
Okay, so we literally did, and I just add to what you had Paul's answer there. I think, from my perspective, one of the challenges maybe from industry is lack of support. So obviously a lot of the applications we've seen today and you described here are very, very well developed, very well elaborated, very bespoke. And then obviously, in order to scale it up, you need people, you need companies and people who are willing and able to support these applications, particularly with I suppose what you see in the cost sector is that the updates, items change, elements change very quickly, within a year, and so maintaining the long-term support may be the challenge that I would see.
Okay. Perfect. Paul, my other question was triggered when you showed the maps about prediction of risk and so on. And I guess what I would like to hear from you is some of these predictions, if you start to think about things like AI, predictive models, and so on, a lot of the money that goes into the AI side of things, particularly, not necessarily with the the geospatial side, is basically building proprietary models to do these predictions. And if you could comment about what you think about AI for those kind of predictions, is there a role for FOSS? How do you sort of see some of that? Because that's what, if you believe the hype, that's future, let's say. So
yeah. I mean, to counter that, you'd say a lot of these predictions, you want that expert opinion. And sometimes I feel with AI and some of those tools, you're chasing the percentage. You might get a slightly more accurate model in the current time, but you lose a lot of the understanding of what's going on there. So I certainly don't think that it negates its role, but I certainly think from an engagement perspective and a sectoral perspective, you want to try and understand why you're seeing those changes and why you're seeing some of those things, as opposed to having maybe. And again, it's that constant trade-off between understanding and prediction. Do you want to understand it or do you want to predict it? And sometimes they can really be at odds. But in terms of the role of kind of I think it will have a role. Undoubtedly, it will have a role, but it will come down to who's undertaking that work. And that's one of the great things that Med-Erin are funding this, is that obviously this is going to be open source and it's going to be out there. But obviously, if someone else is funding it, there's a lot of work that goes into developing these tools, and you can understand why that can sometimes be proprietary.
But in that project, did you see resistance to the predictions? Did you see people questioning the predictions? How did you come up with this prediction? Things like that?
A lot of the time, the discussions center on what you've chosen as the exposure and the vulnerability. Less so the actual predictions. It's more, why haven't you considered this variable, or why haven't you considered this variable? Which is actually promising, because it's showing a level of kind of a desire to want to understand why you're seeing it, and engagement and expertise in that area, as opposed to a blind faith in this is where it's going to be, this is where we're taking it. Yeah.
Thank you. Any other questions?
Question just on the data sets. You mentioned that Edinburgh will open.
Yeah.
Like the CCTV camera locations and stuff like that.
Yeah.
So
Pardon?
they have.
They've got their own kind of geo portal with all of their city data is open. I mean, I think someone said earlier the UK has a very good ecosystem of data sets. But yeah, if you type in Edinburgh GIS data sets, there's a whole portal with something like maybe 240 odd variables out there. So yeah.
I'm just going to go from the other point of view then.
Yeah, you can completely flip the question, right, and identify where there's less CCTV. But yeah,
In that case, thank you. Thank you. Yeah. Well, for the next speaker, it's Kevin from Kulcha. He's going to talk about dashboards. I'll just raise my hand when it's time.
Sure. Yeah. Sorry. Do I just no? I have to do one little job here first.
Right.
You bear with us, folks.
We're just there now.
Now,
Okay. Yeah.
thank you. I'm all set. So
Yes.
yeah. So yeah, this is using interactive dashboards for communication. My name is Kevin O'Brien. Essentially, there's sort of two parts of this talk: public outreach and also engaging the public in the process of scientific and data analysis in a way that sort of allows them to become part of the process. This is a sort of age to discussion in the age of misinformation and misunderstandings about scientific processes. Is sort of it's an enabling sort of way of engaging people for how to become part of the overall scientific process. So I think I'll just, sorry, I think I missed my mark. No, there I am. I just was going to put something there actually at the start, but I just misorganized have to reorganize my slides a bit. My name is Kevin O'Brien. I'm a resource modeler with Quilcha, which is to say a forestry statistician. But importantly, this talk is not really connected to Quilcha because they'd kill me because, Anyway, and also actually more to the point, it would sort of predates Quilcha, to be honest with you. So it's not really connected with Quilcha. This sort of really is connected to some sort of things I have done previously. So about 10 years ago, there was a sort of collective in London called the Climate Change Coders Meetup. And this part of it comes from there, but a couple of other things there about sort of public perception and also engaging with citizen science. I worked in audience research in the Jameson Dublin International Film Festival, which was essentially market research, but also exploring how people felt about the film festival, how they found out about the film festival, public perception of the film festival. Sort of a bit of the same with the JuliaCon, Julia Programming Language Conference, a bit about the public outreach for that. With the YR Foundation, it was more so engaging in citizen science initiatives, okay? So that is sort of where this talk is coming from. I'm just going to sort of go back a little bit. So this is, this talk is centered around essentially our programming language. Now, I'm working under the assumption that a lot of you actually will be have some sort of familiarity with the R programming language. That's the people in the room, and probably you're not the audience I really need to be talking to. More so, it's probably the people who will be watching this video after the fact, more career young people, okay? So the people in the room with me, just bear with me a bit, actually. You might get some ideas about that. But if you're not familiar with R programming language, it's an open source programming language for data science, data visualization, statistics, data processing, GIS, and so on and so forth. So just with regard to the key thing we're going to do right now is just that there are two main tools there, Flex Dashboard and Shiny apps, okay? Now, so there's sort of the two main platforms I might recommend for somebody who's interested in that sort of thing to, explore, okay? So I'll just talk about both of them briefly because I can't really properly give even for one of them, I can't even properly cover it in 15 or 20 minutes, let alone two of them. So there'll be a couple of things I'll sort of high-level comments I'll give, and then just to sort of leave a couple of things for your homework, essentially, the people at home. Now, just as a sort of quick remark, I've amended this talk because I realized that the layout and the format that I had intended would not suit the live stream, okay? Because I realized that chopping and changing between screens would just be a nightmare for Peter. So I just to sort of switch things around a bit, actually. So bear with me. It wasn't what I planned, but, anyway. So just a sort of a taster of the end result. I'm looking at a thing here called the Future Forests by Absalon. Now I have the that's a Shiny app, and it sort of discusses the future of species distribution of various trees, tree species around Europe over the next couple of decades, given a couple of scenarios, okay? It's a very interesting tool, okay? And it's very interesting tool for public engagement, about people who be interested in climate change and how it will affect knock-on effects like forestry, because I think, going back to what I said about Quilcha, I think forestry is a very interesting subject for a lot of people in Ireland. But it's important to actually be informed and allow the public to be informed about that and find their own way through what the reality of it is, the scientific reality of it is, rather than reading about stuff on Twitter from people who don't really know what they're talking about. Okay, so this is a very advanced tool. Now, the thing about this is that I was looking at the code. It's not exactly. It's actually fairly advanced, but it would not be beyond the range of anybody who's would be able to sort of commit a lot of time and resources to it. There would be, there's a good bit of code in the background, sophisticated code, but for a master's students of forestry, this would be probably realistic. If they had a few weeks at it, okay. But there's also a couple of elements to it that are essentially web ops, like CSS. I don't know if people in the room are familiar with that. Just the sort of the user interface component of websites, okay? Cascading style sheets. Now, so why this might be interested and what it might connect with is just a sort of different side of this. This is one of many citizen science projects around Ireland that I've sort of seen that allows people to engage with the scientific processes. In this case, it's biodiversity, natural habitats. And this is Dragonflies, a sort of survey around Ireland that allows people to sort of give people a chance to, help collate a national biodiversity data set. I think it's very interesting. It allows the public to engage in the scientific process, see where the results go, and so on. I think that's a very powerful tool. There are other ones that, additionally to that, there is something I've seen in London about air quality, that the effect of air quality data sets that they sort of collated and presented in a geospatial manner, okay? And again, it was actually done at a sort of citizen science level, which is very interesting. So it's sort of, a great degree of sophistication, but in terms of the output, but the not a massive amount of input. And in fact, not a massive amount of technical knowledge, okay? There's people who are probably dealing with R every day, but I'm talking about people who have only seen R for the first time, have only been using it for a couple of weeks, okay? So that's the sort of where the open source JS movement, let's say, is a great sort of vista for progress. Okay, now I covered that already. Now, so just a couple of things there. I was talking about the importance of public perception. I sort of covered that already. Career young professionals, who this talk is for. Career young professionals in GIS with minimal exposure to open source GIS tools and programming languages such as R. They're familiar with it, but you want to find out the names of a couple of useful R packages, okay? Those who are seeking to migrate from proprietary tools to open source tools. Those who are dealing with resource constraints, who want to replace proprietary tools with open source tools and sort of see what's there, what the options are. And also just a sort of case of enabling citizen science. Okay, so just where I sort of came across this stuff for the first time was about 10 years ago. There was a chief scientific officer with the UK Department of Energy and Climate Change. His name was Professor David J. Mackay, and he actually had this initiative to use dashboards to engage the public and about carbon emissions and their carbon budget, let's say, okay? It was actually quite good and quite ahead of its time. Now, the thing is, two parts to it is that I think it's sort of that department got stood down, it got merged into other departments, okay? And so I think it's sort of lost in the wilderness of time. But also a second thing is that I think it was sort of very ahead of its time, and that the technology was not there for people who were involved in the London Climate Change Coders meetup. That's sort of why it fell apart. It was not really, the technology was not there yet. So it's sort of caught up in it now, okay, that we have these sort of tools available to us now. And so that was a sort of, if it was trying this again, we'd be able to have a much more detailed discussion about it. If the if there was a UK Department of Energy and Climate Change, you would be able to have much more sophisticated tools that people will be able to engage with. So I'm going to rewind a little bit here and just talk about my own little hobby project, okay? And this is called the London Explorer, okay? This is a very simple website, and I was going to increase the complexity of it or get it prepared, but then I was sort of thinking about it and said, no, I'll leave it alone, actually. Just to sort of, you can have a look at it there, okay? Now, this is really just a hobby project. It's sort of locations in London that me and my friends, we sort of socialize in London, where we might be interested in going, interested in seeing, and so on. This is actually a very simple construction. I mean, it's not a great layout. It looks very amateurish, but by the same token, this literally took about 2 or 3 hours to put together. Okay, hacking, borrowing a couple of things such as a CSS style sheet. We actually just to sort of like put this together very quickly. It was, you know, that's sort of the point, actually. So you can imagine we're having a little hackathon. That there's only a handful of us here who have any familiarity with R. We've only got one day. We got a lot of willing volunteers in the room who want to help out, who want to learn, who want to engage, and will sort of be part of the process. But how do you sort of utilize that effectively? Okay. This actually is a very straightforward construction. So there's a couple of components to it. I'll just actually first off give you a sort of second look at it there, just the functionality. This is sort of something I was going to demonstrate with a live demonstration, but just because that would just mess up the live feed, I just had 2 still shots there, that would sort of make it easier to follow. So Pete, you can just sort of have a look at that on your laptops and so on. Okay, so there's a little bit of extra sophistication. Arvid, who actually added a data set, he's not technically, he's quite technically competent, but not in this respect, but he was able to sort of do a pull request and put in his own little data set there. I was going to sort of progress it further, but you know, so essentially this is sort of allowed collaboration. This is a hobby project, so interesting places to visit in London. So I sort of covered a couple of those points there. But just to remark upon that the construction of this uses a couple of our packages, okay? Flex Dashboard, which is a simple framework for interactive dashboards. I'll give you a quick look at that, how that might work out. But essentially what that does is sort of knits and compiles a series of R Markdown documents together, okay? R Markdown is a sort of literate programming tool that allows you to sort of combine R code with R plots and R outputs with a sort of descriptor in a sort of HTML format, okay? So it's very straightforward enough. There is an interactive tool called Leaflet. Now, Leaflet is a sort of a broad interactive tool that I believe a lot of people in the open source GIS world would know about. I won't go into it too much detail, but just to remark that this is a very useful package, and I was able to sort of quickly deploy it to make this little website here, okay? Beyond that, we have Tidyverse, a family of data processing tools that most people should be fairly familiar with, and then a cascading style sheet that literally just sort of improved the layout. 4 elements, and to be honest with you, nothing of there was beyond the technical skill set of anyone who wanted to pick it up very quickly within a few hours. I'm talking about beginners, okay? So essentially what I'm saying is that this is essentially something that a citizen science who's maybe interested in dragonflies, maybe interested in carbon emissions, maybe interested in bat sightings, they want to take that knowledge and sort of progress it forward, okay? And I think that's a sort of very useful thing to bring to the table in this day and age. So written in R Markdown, I specified the layouts. Again, R Markdown is essentially what I'm writing this in, essentially, this presentation. It's just a way of sort of formatting text, essentially. It was quick to build and deploy, and essentially what I did to deploy it is I set it up as a repository on a dedicated GitHub organization. Just a quick question. Most people in this room, I'm guessing, would be familiar with GitHub, yes? Yeah, okay. So, but just sort of take the view that maybe a career young person maybe not so familiar with it, okay? So, this is and it's a very straightforward process. And again, just a sort of key point here about citizen science, that non-technical people were able to contribute to it very quickly and effectively, and improve their own sort of skill sets that they've further developed, okay? Now, I won't go too much further with that, but just to sort of one remark is that this is something that I found that a lot of people did not know or realize. That I could talk about how to do our markdown, but I'm just wasting your time, basically. There is one thing I would say is, if you're using our markdown documents or flex dashboards or anything like that, there is a way of modularizing your code, which allows you to break up the code chunks, sort of look up bit by bit, and then sort of knit them together and piece them together and code them, incorporate them or comment them out, and just to sort of allow you to iterate it. So that's one very useful tip for working with or markdown code, the child thing. So essentially, rather than have one big long piece of code, modularization and compartmentalization. Again, I won't go too much further with this, just to remark that there is one Coursera course that will allow you to develop your skill sets with Flex dashboards and Shiny apps on a ongoing basis, rather than, this is just a sort of, rather than listening to me try to talk about it, I just sort of say, listen, there's a course here, it's very good, check it out, okay? And that will allow you to sort of develop all the skill sets to make very sophisticated dashboards. Now, I just talked there about Flex dashboards. They're very simple in construction. What I showed you at the start was actually a Shiny app, which has actually much more technical sophistication behind it, okay? So it's a web-based dashboard, and it can be developed using R and Python, okay? It's more technically sophisticated because it allows the user to specify arguments and inputs that will allow, greater degree of control, greater degree of contingents, demonstrating various contingencies and scenarios. So this is just an additional thing, is that how to actually use a Shiny app, or how to sort of get good at it, is actually just do it for real, okay? A lot of people will build Shiny apps on their laptop and just press the run button, and then it works on their laptop and it compiles, and that's great. But I think really there's a lot of skills and habits that are best developed by trying to deploy it for real on a proper platform, so it's permanently up there online and permanently visible in production, as they say. So essentially, the best approach there really is to actually just set up an account on one of the various platforms that allow you to host Shiny apps, for example, shinyapps.io, and just build for deployment. Actually sort of think, I'm going to put something into construction that's going to be up on the web tonight or now, essentially, and just sort of build with that focus in mind, okay? Because what will happen there is that you start to realize that when you're working with the cloud environment, not just on your own laptop, that there are little sort of different rules, different constraints, different requirements that you need when you're working on the cloud, okay? So you might not sort of see them. You're not really taught them when you're learning R, okay? Because when you're taught R, that's not what the focus is. But it's when you're working with cloud environments, it's the requirements are different. So the one key thing to sort of look at there is the log files in your Shiny apps, and that will sort of tell you how it's getting on, where the problems arise, what the constraints are that are different on the cloud as opposed to on your laptop. Okay, so that's the one key thing to sort of take away, is that the log files are there, your friend. Get used to working with them, and so on, and that will help you get very good at putting Shiny apps up. So yeah, when you are ready to go, the process of actually deploying your Shiny app, which will be set up in a folder called My Shiny App, is very straightforward, and it can be done at the command line. There is an R package called RS Connect that will allow you to deploy them very quickly from the command line. Okay. Now, there is one thing I'm actually going to sort of remark. I sort of cut through a lot of the key things here. But just to remark about how to build and how not to build Shiny apps. There is a certain level of sophistication that it's, there's no avoiding the very sophisticated approaches, the very sophisticated internal architectures, okay? And if you're having to face that scenario, the best thing to do is really get an experienced Shiny developer in, okay, who is experienced in dealing with all these little scenarios. But for cost constraints, time constraints, or maybe you're not really far enough along in your journey that you need that. Maybe you need something very simple construction, but that still looks good and still has a high degree of sophistication. Okay, so there are quite a lot of workarounds, not workarounds, but sort of subtle tricks that people sort of forget about. Okay. Now, one of them that I sort of a big fan of, I've seen some presentations about building Shiny apps, and people were actually having very long, sophisticated code bases inside their Shiny apps that would process all the data and generate all the plots, okay? The reason for that is that whatever is going to be presented in the Shiny app must be uploaded into the cloud. Your calculations cannot be done from your laptop and pass up to the cloud. So everything has to go up in one go. Okay? So either you put the code, the raw data sets in with the code that processes them. Okay? That's fine. And it's, a sensible approach in a lot of cases. But it may be the case that you get to sort of certain levels of sophistication where that's just complicated and messy. Your code base starts to fall apart. Shiny apps are very hard to debug. I don't know if anybody's dealt with them. Like even a loose comma or a loose bracket can cause havoc, right? You want things as simple as possible, running like a kitten, purring like a kitten. And again, more so when you are working with non-technical people who have no experience with Shiny apps, okay? So an approach I would sort of recommend there is that you actually pre-process all of the outputs that you might require, okay? Now, this is sort of assumes a sort of certain level of sophistication, a certain finite number of scenarios that you're going to be working with. Like, that's a sort of countable number of scenarios. There comes a point where you have to sort of say, if we only need 5 or 6 scenarios, we need a plot for each scenario. Rather than processes it on the app, can we just pre-process everything? Okay, so a different approach to take there might be to pre-process the data objects before deployment and store them in an R data file or an RDS file. There's actually 2 of them in the Shiny app folder. So there's actually the R data files and RDS files, which is sort of the same thing essentially. Okay, I've actually sort of made a slight. This is just a bit of code that I had sort of ready, okay? So what this will do is just set up a few objects and collect them up as a list of objects there. So what we have there at the top, Project A1, Project A2, Project A3, Project A4, they're essentially just a list of R objects. They could be plots, data sets, and so on, okay? Essentially what the best approach here to take is that you can just sort of collect them up, anything that has project in the name, collect it up as a little list, and save it as an RDS file, okay? That's an R data file, and transfer it to the Shiny app. So send it over to the Shiny app, save it over there. It's in the Shiny app. When the Shiny app gets uploaded, these R data files will get uploaded as with it. and you just load them. Have a look on your Shiny app program. You have a little load our dataset file, and they will be available. A couple of other things there. I'll just sort of skip past that. There's a couple of useful little things there. Just one little sort of interesting problem to look out for. This is a sort of an ongoing discussion in the R community. It's the expert beginner problem. A lot of people have been using R for the last 4 or 5 years, maybe 6 or 7 years, and they're very familiar with a certain set of tools. And that is, everything they feel they need. And I think that's a big mistake. And I think this is a sort of a big problem that is arising where people are sort of hitting these, hitting the wall essentially, and they're not able to sort of get past it. Very simple things. And essentially what happens is that it leads to a lot of unhelpful discourse. For example, for loops are bad in R. They are, but there's a way around it. In fact, if they're really bad, it's because you're doing something wrong. There's nothing really to do with the for loop. You hear a lot of that, okay? So there's a sort of danger of intellectual comfort zones. So something I highly recommend is taking the initiative to improve your code vocabulary as much as possible. Tidyverse, base R, all the other flavors of R that are out there. Because what you'll find is that there is solutions here, there, and everywhere. And beyond R as well, Python and Julia, beyond R as well, do not settle into an intellectual comfort zone. I think that's it. Yeah, we'll leave it there. Yeah.
Thank you. Thank you, Kevin. Just have a round of applause.
Thank you.
I will build up for some questions. I have a couple, but maybe we take from audience some comments, questions.
Just to ask, I take your background is obviously R, but in terms of developing using Python, have you any experience in that, and how did that kind of compare in terms of process?
I think actually not familiar with it, but I think the processes are pretty much catching up. That more so, it'll get to the extent where Shiny will be sort of language agnostic very soon. I think Python's still in a bit of catch up, but give it 2 or 3 years. I think everything I'm saying about R will have a direct equivalent to Python. I just don't have enough experience with Shiny and Python. Yeah, give it 2 or 3 years. I think it'll be a level playing field. Yeah.
Thank you. I have a couple of questions. The first one being maybe a bit more commercial-oriented question. Is citizen science a hobby? Is it a business?
No, it's essentially a hobby. It's a sort of allow people who are sort of very interested in natural sciences mostly, or environmental sciences, sort of as a hobby that allows them to engage in scientific processes, but at a sort of casual level. They want to go out and it's a hobby thing essentially. But they're not doing it at a very serious level. But essentially, the idea is that if they do it well, they're building really useful data sets.
Have you seen examples in your experience where people are trying to build businesses out of this stuff?
There is. I'm not sure if it is a business, but there is a not-for-profit. Let's say there is. I believe there's an initiative in Cork about litter, prevalence of litter. I don't know that much more about it.
Open litter method.
I think that might be it. Yeah.
Thank you. And I guess I have one comment on it. What you're trying to say, I guess, in your talk is become a creator rather than a consumer of this.
Yeah.
Which is sort of a bit more active and engaged. The follow-up to this is a lot of organizations are afraid of engagement, are afraid to hear what the people have to say or what they think about it.
Yeah.
I guess if you can talk, particularly with your experience with the film festival and others, how do you overcome the barrier of engagement or the preconceived notions that organizations and people have about, oh, maybe I shouldn't ask this question because of what they will say or something like that?
I think it's this not related to the film festival now, but it's essentially allow them to be part of stakeholders in the process at an active level. Okay, and this will sort of incentivize them to actually be, rather than just sort of consumers of information they get on social media, they're a bit more active about it. They want to sort of see what their contribution goes where it goes, how it's, you know, down the pipeline of the decision-making process. Now, they might follow this pipeline or this sort of decision-making process more intently, and then they start to become more attuned to the trade-offs that are, you know, have to be made. Okay, so it's essentially it incentivizes a greater understanding of the overall decision-making processes. Okay, it's a sort of strange answer, but if you sort of follow the logic.
No, I think you're saying the same thing that I kind of alluded to in my talk as
well,
where this engagement de-risks some of the objections.
That's right, yeah.
Or something like that, where people at least perceive to be a part of the solution or something like that.
Yeah, exactly. I mean, it's a sort of, they're a bit more mindful of the trade-offs that need to be made. Exactly. They're fine. No, actually, at a corporate level, they're fine. I don't have anything against them. It's essentially where I'm coming from is, first off, there's a cost associated with them, and there's the sort of training cost.